Let's look at the integration method, integration by parts. So the formula for this is if you have u dv, that's the same as uv minus the integral of v with respect to du. So this kind of looks like product rule for when you're doing derivatives, but in product rule you can use u and v as whatever you want. It doesn't really matter what you put it as. But when you do integration by parts, you have to actually think about what you're setting u and dv as. So here's a formula that you can kind of use to see what you want to use as u and dv. So the first is logs, second is inverse, third is algebraic, and trig is fourth, and exponential is also fourth. Trig and exponential are on the same level. And now let's say we have a function like the integral of x e to the negative x. You see here we have x, which is algebraic, and e to the negative x, which is exponential. We would take x to be our u because that comes first. See, 3 is before 4, and e to the negative x is last, right? So we would take e to the negative x as dv. So this is just a little structure that you could use to see what your u and dv is. Question 1, we have x e to the x dx. So we have an algebraic function and an exponential function. So let's see here what comes first, and we see a, which comes before exponential. So we're going to set our u to be x, and now we're going to set our dv equal to e to the x, because that's that's in the last. So e to the x. And now we're just going to differentiate du with respect to x. So du is equal to the derivative of x is just 1 dx. So du equals dx. And now we have to integrate our e to the x because we're trying to find v. So the integral of e to the x is just going to be e to the x. And this is also with respect to x. Now let's plug it into our formula. So uv is equal to x e to the x minus the integral of v du. And here we see that du is equal to dx. So we're just going to leave it as e to the x dx. And also we know that the integral of e to the x is just e to the x. So the final answer will just be x e to the x minus e to the x plus c. And that is our final answer. Question 2, we have the integral of x squared ln x dx. So here we have an algebraic function and a logarithm function. Now we see that logarithm is on the top, which is first, right? So we're going to take ln x to be our u. So whatever comes first is going to be our u. So u equals ln x, and we're going to set our dv equal to x squared dx. Now we're just going to differentiate u. So du is equal to 1 over x. The derivative of ln x is 1 over x dx. And now we're going to integrate this function. So the integral of x squared is just x cubed over 3. So v equals x cubed, or x cubed over 3. Now we're going to plug it into the formula. So uv is just going to be x to the 3 ln x over 3 minus the integral of v. And it's v du, right? So x to the 3 over 3, and du is equal to dx, or du is equal to 1 over x dx. So dx over x. And now we can cancel off this x, so we can simplify a little better. So this is going to be x squared 1 over 3 dx, and this integral right here is just going to be x cubed over 9, because the integral of x squared is x cubed over 3, and that's divided by 3 again, so x cubed over 9. So now let's put everything together. We have our uv, which is x cubed ln x over 3 minus our integral here, which is x cubed over 9 plus c. And that is going to be our final answer. Question 3, we have x sine of 3x dx. So here we have an algebraic and a trig. So what we're going to do is we're going to set x equal to u because that comes before a trig. And we're going to set sine of 3x equal to dv. Okay, so u equals x, dv equals sine 3x dx, and we're gonna differentiate u, so du is equal to, and again the derivative of x is just 1, so dx, and the integral of dv, which is sine of 3x, so v is equal to, when you integrate sine of 3x, this is just going to be negative 1 over 3 cosine 3x. Okay, now we're going to use a formula. We're going to use a formula again. So uv is going to equal negative x cosine 3x over 3 minus the integral of v. And since du is equal to dx, we're only going to integrate this right here. So actually, we're going to take out negative 1 over 3 first. So this is going to be a plus 1 over 3. So it's easier to integrate. Cosine of 3x dx. And now let's look at only this right here. So the integral of cosine 3x is just going to be 1 over 3 sine 3x. Now let's put everything together. So this is uv, which is going to be, let's write over here, negative x cosine 3x divided by 3. And this is 1 over 3 multiplied by the integral, so plus sine 3x divided by 9 plus c. And that's our final answer. Question 4, we have the integral of e to the x cosine x dx. So now we got to the part where we have two functions that are both, or not both, one is trig and one is exponential. So since they're in parentheses, they're both on like the same level, I guess. What you can do is you can set u to equal either of them and dv to equal either of them. It doesn't matter if you say u equal to e to the x, or u equals cosine x, or dv equals e to the x, or dv equals cosine x, because they're both trig and exponential. So let's just keep it how it is, and let's say u equals e to the x and dv equals cosine x dx. It really doesn't matter what you set them equal to as long as it's u and dv. And now let's differentiate u. So du equals the derivative of e to the x is just e to the x dx. And the integral of cosine x is, so v equals sine x. Okay, now let's plug into the formula. So uv is e to the x sine x minus the integral of v du. So e to the x sine x dx. Now here we can't really simplify anything to get a simple integral. So again, what we're going to have to use integration by parts one more time. So let's just take, we're only looking at this integral now. So let's say u equal to e to the x again, dv equal to sine x, and we're going to have du equals e to the x, v equals, the integral of sine x is negative cosine x, this is dx, and now we're going to do uv, so negative e to the x cosine x minus the integral of v du. So since this is negative cosine x e to the x dx, I'm just going to remove the negative and add it over here. So it's just going to be e to the x cosine x dx. Now we're back at our original function. You see here, Our original function is e to the x cosine x dx. And again, we have the integral of e to the x cosine x dx. So what we do here is all the stuff we've evaluated is equal to the original function. So what we're going to do here is we're going to say this function is equal to everything we've integrated so far. So our first integration by parts, we got e to the x sine x minus the integral of e to the x sine x dx. And once we integrated this, we got this. So now let's write everything out. So e to the x sine x. And then we have to distribute the negative, so this becomes plus e to the x cosine x, and then distribute the negative again, so minus the integral, we just keep the integral here, we're not going to solve it, e to the x cosine x dx. Now, all we have to do is solve for this integral. So we're going to add this on both sides. So we're going to have, let's just draw a line here, 2 integral e to the x cosine x dx is equal to e to the x sine x plus e to the x cosine x. And now all we have to do is just divide by 2 on both sides. And now our final answer is, so the integral of e to the x cosine x dx is equal to e to the x sine x plus e to the x cosine x divided by 2 plus c. And that is our final answer. So if you have a trig and an exponential function, it doesn't matter what you say, u or dv, and just make sure when you get back the original function, which usually happens at the second integration by parts, don't keep integrating or else you're just going to keep going and it's never going to end. Just make sure to set this whole thing equal to everything that you've integrated so far. So set equal to the first integration by parts and add it to the second integration by parts, and you just have to solve for that function, which we did here, and you get your answer, e to the x sine x plus e to the x cosine x divided by 2 plus c.